Hello everyone, welcome to Driven Maths and Physics. Thank you so much for tuning in today. And today we'll just do a couple of problems on uniform circular motion, and then we'll see where that takes us. Now I want you to be pausing the video every time we're starting a new problem, and then try to solve it on your own, and then play the video again so that you can see how the solution is arrived at. Okay, so as we're starting this one, pause the video and then try to solve it on your own. Let's see how far you have learned so far, and let's see if you can come up with a correct solution. Okay, now let's begin. The first problem before us is a cyclist travels at a speed of 12 meters per second on a bicycle which has wheels of radius 0.4 meters. Means they're saying calculate the frequency of rotation of the wheel. Okay, first thing that we know is that we're given the speed, which is 12 meters per second, and we also know what we've been given here is the radius of the wheel, which is 0.4 meters. Okay, so those are the things that we actually are aware of. Okay, now given the speed, given the radius, we need to recall the formulas that we have come up with so far in this topic. Okay, the first one is that V is equal to omega times r. That's the fundamental relationship between velocity and angular velocity, okay, or angular speed. Now from there we also came up with 2 pi r f. This was the other formula for speed. And then we had V is equal to 2 pi r over periodic time. That's another formula that we came up with. Okay, now what we're given here is that the frequency, we're given the velocity and the radius, and they want us to find the frequency. And here in this formula we have velocity, we have radius, and we don't know the frequency. That's what they want us to find. Now making f subject to the formula, in that formula will be f equals, so we're solving part A, f equals V over 2 pi r. So this will become 12 meters per second. Okay, 12 meters per second. That's what we write. Divided by 2 times pi times 0.4 meters. Okay, and what we see is that everything is in the same unit. So the meters are in, every unit is in meters per second, the other one is in meters. Alright, so we can work this out quickly, and that will become, let me just do it on my calculator. It will be 12 divided by 2 times pi times 0.4. This gives us 4.774 hertz. Okay, that's the frequency that we found. Alright, so from there they also want us to find the angular speed of each wheel. So this is angular speed, in this case is omega. So we know V, we know the radius, they want us to find omega. So part B will be omega equals linear speed over r. So the linear speed in this case is 12 meters per second. Then we'll divide that by the radius, which is 0.4 meters. When you do the calculation here, 0.4, it gives us 30 radians per second. Remember, angular speed or velocity is always in radians per second. So once you know that, you'll never go wrong. Okay, now then let's do part C. Part C is telling us to find the angle of the wheel, the angle the wheel turns through in 0.1 seconds. Okay, the angle. Now when they're saying the angle that the wheel turns through, you automatically know they're talking about theta, which is angular displacement. Okay, so they've given us the time that they want us to consider, and then they want us to find the angular displacement. What formula should we consider? Remember that angular speed is equal to theta over time. Okay, that means if we make angular displacement subject to formula, it will be omega times time. Okay, so we know the time that has been given, we know the angular speed that were found there. So it means angular displacement will be equal to omega times time. This becomes 30 rads per second multiplied by 0.10 seconds. When we do the calculation, we say 30, it'll actually give us 3 times 0.1. So it will give us 3 radians. The seconds cancel out. Okay, 3 radians. That's the angular displacement. Okay, that's the angular displacement that we're getting. Now remember, this is in radians, so the radians part is done, but they want us to also find it in degrees. So how we're going to do that is easy. Let me just remove this these things on the side so we can have space to solve. Alright, so let's look at the final part of this question, which wants us to find the angular displacement in degrees. Okay, we know that fundamental relationship that I told you to always remember is that 2 pi radians is equal to 360 degrees. Okay, 2 pi radians is equal to 360 degrees. Therefore 3 radians will be equal to 3 over 2 pi multiplied by 360 degrees. When we calculate this, so 3 divided by 2 times pi, when you calculate that multiplied by 360, what we get is 171.89 degrees. That's the answer we get. So the same angle that we sweep through in radians here as 3 radians is actually 171 degrees in degrees. So yeah, that's how you arrive at these solutions. And so I want you to compare with what you calculated and what were found here. Have you found the same solutions? If you have, congrats to you. It means you're learning something and this is becoming easy. Okay, now let's look at the next problem. All right, here's the next problem. Now the next problem says a cyclist travels wait a sec, is this a repetition? Yeah, that's a repetition. Let's see this side. Okay, sorry about that. Alright, let's do this one. Sorry about that, just making sure that I'm talking about the same thing. Okay, so let's do this one. It says a satellite in a circular orbit of radius 8,000 kilometers takes 120 minutes per orbit. Calculate its speed, and then we should calculate its angular displacement in 1 second. Okay, so what you notice from here, first of all, is the information that you're being given. The first thing is that we have the radius, which is 8,000 kilometers. 8,000 kilometers. If we convert this to meters, it's 8 million meters. Okay, the second thing we're given is the time per orbit. This is literally the time period. Capital letter T is 120 minutes. Let's convert that to seconds. It's 120 times 60. The whole thing will be in seconds. That's 7,200 seconds. Okay, so that's the information that I've been given. So part A says calculate the speed, which is v. Now, with the information given, the periodic time and the radius, let's recall the formulas for speed. So we have 2 pi r f, then we have 2 pi r over capital letter T. That gives us v. So in this case, we have the radius, we have the periodic time. That means we just say is equal to 2 pi r over capital letter T. Alright, when we substitute, is 2 times pi times 8 million meters divided by the periodic time, which is 7,200 seconds. When you do the calculation here, So it has 2 times pi multiplied by 8 million divided by 7,200. That gives us 6,981.317 meters per second. Okay, that's the answer we get. Now, after calculating the speed, let's look at how to calculate the angular displacement. Okay, so we know the speed, we need to know the angular displacement. How do we calculate the angular displacement? First of all, we have to know the angular speed, because angular speed is equal to theta over t. So once we know the angular speed, we can know the angular displacement. Remember, they want us to find the angular displacement in degrees and also in radians in 1 second. Okay, so the first thing we need to do is calculate the angular speed. Now, angular speed will be equal to, remember that v is equal to omega times r, therefore omega will be equal to v over r. So this will be v over r. The v that we've calculated, 6,981.317 meters per second divided by 8 million meters. That gives us what? Okay, divide by 8 million. That gives us 0.0008727 rads per second. Okay, so you can see that we have this amount of angle, 0.0008727 radians in 1 second. So the angular displacement in 1 second will simply be 0.0008727 radians. Since we have the angular speed and it's already per second, it means in that 1 second we cover this amount of angle. So that's what we've written there. So we know what it is in radians. Let's calculate what it is in degrees. Okay, so if 2 pi is equal to 360 degrees, therefore 0.0008727 radians divided by 2 pi radians multiplied by 360. This one is what will suffice here. Okay, so divide by 2 times pi. That gives us that multiplied by 360. It gives us 0.05 degrees. So that's the amount of angle that we're going to cover in degrees. All right. Yeah, so this is how you approach this problem. I don't know if you found the same solutions after pausing, but if you did, kudos to you. It means you're learning something. And yeah, this is how you approach the problems, and hopefully this is helpful. I think we should really do more practice on this. Always be familiar with the formulas that we have been looking at in uniform circular motion. And once you know the formulas, once you know what you're given, and then you decide where to apply which formula, once you get used to that process, uniform circular motion will never be a problem for you. So it's a very straightforward topic, and I hope this has been helpful. Thank you so much for tuning in. Don't forget to like and subscribe. Thanks.